Okay, an object is 20 centimeter in front of a glass block with a concave surface of radius of curvature 10 centimeter. Find the position of the image formed by refraction at the concave surface. Okay, this is a concave surface to the object. Okay, so here again he asks for, hold on a second. Yeah, so this question again asks for position of image. So he wants the image distance. Okay, so by the look of this diagram, this is considered refraction at one surface. Yeah, at refraction at a spherical surface. So here we have a glass block. Just want to color it. Yeah, this is the glass block. Okay, whereas outside is the air. Yeah, outside is the air. They already give you the refractive index, okay, of the glass. Okay, outside should be air. Yeah, air. Refractive index of the air should be 1. Okay, refractive index of the air normally is 1. Refractive index of the glass is 1.5 or sometimes 1.52. Okay, so here he give you 20 centimeter. This is the object distance. Yeah, object distance of the distance of object from the surface of glass. Okay, so this is the object over here. I want to draw it out. Okay, we have an object over here. Okay, and this is the object distance. Yeah, or from object to the surface. This is the object distance. This one should be the U. Yeah, this one should be the U. Object distance. Okay, from here to here. Yeah. All right. And this is a concave surface to the object. Okay, he give you this radius of curvature 10 centimeter. Radius of curvature of concave surface. This is a surface. Radius of curvature is the distance from the surface to the center curvature of the surface. So we can say that if you look at here, the center of curvature of this surface should be around here. This is a center curvature. Center curvature. So the distance 10 centimeter, radius of curvature, is the distance of the surface to the center curvature. This is the R. R, yeah, and this R is 10 centimeter. Okay, that's it. And now we need to find the image distance. Refraction at concave surface. This is a refraction. Yeah, refraction at one surface. So, okay, before begin, okay, what's the formula of refraction at one surface? If you look at my notes, refraction at one surface, this is the formula: n1 over u plus n2 over v equal to n2 minus n1 over r. Okay, write the formula down. n1 over u plus n2 over v equal to n2 minus n1 over r. Okay. All right. So which one is n1 and which one is n2? Which one is n1? Which one is n2? Here we have the refractive index of air, and we have the refractive index of glass. So which one is n1? Which one is n2? We need to look at where is the source of light, where is the object. So object is over here. Object is over here. So first of all, let's draw the incident ray and refracted ray. So incident ray come from the object. Incident ray come from the object. The light come from the object. You must first draw the incident ray. When you do this question, always draw the ray first. Okay, draw the incident ray and refracted ray first. So incident ray come, and this is a refraction. Refraction, that means the light can pass. The light passes. Not reflected. The light passes or refracted. The light passes. So the light enters. Yeah, the light enters. So the light goes to the other side. The light goes to the other side. So this one is the refracted ray. Understand? So for refraction, the light can pass through. So the light come from the incident ray come from the object and it goes into the glass. So where is the N1? N1 is always with incident ray. N1 is always with incident ray. And N2 always with the refracted ray. Okay? So if the light comes from the air into glass, so air is N1, glass is N2. So here is N1 and here is N2. If the light, so N1 is always with incident ray, N2 always with refracted ray. Okay? So N1 is 1, N2 is 1.5. That's all. Okay? Always draw your incident ray and refracted ray first. Then you can determine which one is N1 and N2. Okay, how about the object distance? Object distance is the 20 centimeter. Okay? So is 20 centimeter positive or negative? So go back to our principle, previous, this one. Okay. Our rules. Okay. So just want to copy that, go here, put it over here. Where is it? Hold on a second. Not copy yet. Let's copy. Okay, and put it over here. Yep. So object distance always compare with incident ray. Just like what I say over here, right? Object distance always compare with incident ray. The rest like image distance, radius, all compare with refracted ray. That's the comparison partner. Only the object distance compare with incident. The rest, radius, image distance, all compare with refracted ray. Okay? So if same side is positive, if opposite side is negative. Okay? Let's rub off all these. Yep. Yeah. Okay. Now this 20 centimeter is the object distance compared with incident ray. So is it same side? Same side. Same side. So positive. So it's positive. So this U is U positive. Okay. And then how about the radius? Radius for concave surface in refraction. This radius is over here. So it is at the side of incident ray. It is not at the same side with refracted ray. See that? So the radius compared to who? Radius compared with refracted ray. So radius compared with refracted ray. You see that? Radius compared with refracted ray. So radius compared with refracted ray. So it is it at the same side? No, it is opposite side, not at the same side. So opposite side. So opposite side. So opposite side is negative. So this radius is virtual. This radius is virtual. This radius is negative because not at the same side with refracted ray. Okay. So this R is R negative. This R is R negative. Or you can say negative 10 centimeter. Okay. So that's very simple. So okay, now we can substitute the value. So N1 is 1. Okay, N1 is 1 over and then plus N2 is 1.5. 1.5 and equal to N2 minus N1. Okay, now object distance is positive 20 centimeter. When not SI unit, you must label. You must substitute the unit together with the value. Yeah. When not SI unit, when not meter, when other unit, you need to substitute the unit together. Okay. And then image distance and then R. R is positive or negative? R is negative because it is opposite. It is not at the same side. Yeah. not at the same side with refracted ray. So it's negative. This is negative 10. So you need to put this negative 10. Not just 10. Negative 10. So be careful. This is R is negative. Last time, this convex surface, this R is positive. This R is positive because same side as refracted ray. Same side as refracted ray. This R is positive because same side as refracted ray. Now this concave surface, this R is not in the same side, not at the same side with refracted ray. So this R is negative. This R is negative. Okay? Not in the same side, so it's negative. So okay, so we got it. Continue our calculation. So let's find out. Let's find out the value. So 1.5 over V equals to 1.5 minus 1 equals to, and then divide by negative 10. Okay, and then minus 1 over 20. Go to the other side. Okay, that is, and take the reciprocal, and take the reciprocal already, and then multiply by 1.5. Okay, so just now is this again 1.5 minus 1, and then divide by negative 10, and then minus 1 over 20, minus 1 over 20. Okay, I got this is negative 1 over 10. And find the V. So take the reciprocal, and then multiply 1.5. Okay, so I got this V is negative 15 centimeter. Oh, so I got the V is negative. What does this mean? I got V negative. V negative means what kind of image? Negative V means virtual image. When negative means virtual. So this image is a virtual. Come on, I need the other color. So this is a virtual image. When V negative means it is virtual image. So this is a virtual image because it is negative sign. Okay, I got it, negative sign. Negative image. This is a virtual image. So you get negative sign. So now I want to ask you, where is it from? This virtual image, where is it from? Okay, so I got is it at the same side with incident ray or at the same side with refracted ray? I get V negative. V negative means must be not in the same side with refracted ray, must be opposite side with refracted ray. So the image should be formed at here at the left hand side. Understand? So when okay, look at the V compared to who? V compared with refracted ray. You see that? V compared with refracted ray. So now I get V negative. I got V negative. So V negative means what? Form at the opposite side of the I got V negative. Yeah, I got V negative. Means the V must be, the image must be opposite side of the refracted ray. You understand? I got V negative means the image must be opposite side of the refracted ray. So must be opposite of refracted ray, opposite of here. So it must be over here, opposite of refracted ray. So the image must be formed here. Okay, and negative 15 centimeter, negative 15. So the object is 20. Object distance is 20. So image is just 15. So it must be nearer to the surface. The image must be nearer to the surface. So the image must be over here. Virtual image is dotted line. You must draw dotted line. So this is the image. This is the image. Okay. This is the image. Understand? This is the image. 15 centimeter nearer to the surface. Okay, so it must let's draw it out. So image distance, let's draw. So this is the okay, so this is the V. This is the V. So this V is negative, and I got the V is negative. Don't write. Just I got the V is negative 15 centimeter. Okay, negative 15. So more than the radius curvature and less than the 20 centimeter object distance. So image distance must be over here. Okay, negative 15. So why this V is negative? Why this V is negative? Because it is opposite of reflected ray. Remember, image always compare with refracted ray. Image is compared with reflected ray. Now V, the image is opposite of reflected ray. That's why V is negative. Okay. So why I draw image is upright? Why I draw the image is upright? Because remember the acronyms. The previous example, I talk about this one. This one. I'm just gonna copy this again and put it right here. All right. So right now we are. This is I got V negative. I got V virtual, right? Virtual image. So virtual image is VU, VU. Virtual image must be always upright. Only real image is inverted. This one, understand? So this virtual image must be upright. Must be upright. That's why I draw upright. And it is dotted line. Dotted line means virtual. Okay, so this image must be upright. I draw it upright. Again, and then what else? Okay, another question. Can we see this image? Can we see this image? Yes, of course, we still can see this image. We can see if we are inside the glass, we can see the image. We can see the image. Because why you can see the image? Because the refracted ray come from the virtual image. This is a virtual image. This is a virtual image and it cannot form on screen. Yeah, this image cannot form on screen. You put a screen over here, there's nothing appear in the screen. Nothing appear in the screen. But you can see from here. Why you can see from here? Because the light, the refracted ray goes to your eye. The refracted ray goes to your eye. So what is this virtual image? Virtual image means the light seems to come from this virtual image. Go back to our notes, our concept. What is virtual image? Virtual image doesn't pass through the image, but appears to come from there, diverge from there. So yeah, it's just like this one, refraction. You see that? The outgoing light still seems to come from that point, come from the image. This is the image. This is where the image. Okay, this is a virtual image. Virtual image because the outgoing light seems to come from the virtual image. But this one cannot form on screen. There's nothing there. Yeah, there's nothing there. Cannot form on screen. This is just a virtual image. The light doesn't the light doesn't pass through the image. The outgoing light doesn't pass through the image. But this outgoing light seems to come from the image. Seems to come from the image. That's the virtual image. This is called the virtual image. Understand? We can see. We still can see. But this one cannot form on screen. You put the screen there, nothing is formed there. Cannot form on screen. This is virtual image, cannot form on screen, but still can see. Because the outgoing light goes to our eye. So similarly goes to our example just now. Example, can we see the image? We still can see. But this virtual image cannot form on screen. Understand? you put the screen there, nothing appear in the screen because the light, the reflected ray is already at the other side. The light doesn't go to the image point. The light doesn't go to the light doesn't pass through the image point. So there's no light over here. The light doesn't form image on the screen. Yeah. But the light can enter our eye, so we still can see the virtual image from the glass. We still can see it. Okay, just that this virtual image cannot form on screen. Okay, because there's no light. The light already go to the other side. The light doesn't go to this point. So that's why there's no image formed on screen. Okay, so that's all for this question. I hope you understand the concept. That's all. Bye bye. I mean, this refracted ray seems to come from the image. This refracted ray seems to come from the image. That's virtual image. Yeah, because the refracted ray seems to come from the image. Okay, that's all. Bye bye.